Hi, this is Mr. Lloyd here, and today we're going to do the 2012 June C1 paper from AQA Chemistry. So this is a paper that is relevant if you're taking the 2017 exam papers. If you're taking the paper after that, it's a new GCSE. So here we go with C1. So let's do question 1. So the electronic structure of 4 different atoms are here. Use the chemistry data sheet to help you answer these questions. Name the 2 subatomic particles in the nucleus of an atom. So you can pause it now to think of an answer, or write an answer down somewhere, and then I'll go through the answers. Off you go. Right. Name the 2 subparticles in the nucleus. They are the proton and the neutron. So just look at the mark scheme. See if there's any other extra things. I doubt it. It's pretty straightforward. Protons and neutrons. Ignore P/+ and N/0. Do not accept electrons because they're definitely not in the nucleus. So it's 1 mark for both of them. Also, every exam paper comes with an examiner's report. And that tells you what people got wrong in the question. So since exams are marked based on, since your grade's not based on your score, it's just based on how well you do compared to other people. If you get things right that other people get wrong, you should be doing a lot better than them. Majority of students achieve marks, so a very straightforward question. Why is there no overall electrical charge on the atom? Off you go. Right, the reason is the number of protons is the same as the number of electrons. You can say they balance or cancel out. You can say the positives and negatives balance or cancel out. So there you go. Yep. The examiner's report is probably another straightforward. Many answers were disappointing. The wrong way around on the protons and electrons, or the charge attributed to neutrons. That's a common mistake. Some people think that if neutrons begin with N and negative begins with N, then neutrons are negative, but neutrons are neutral, have no charge, not plus or minus. Some students omitted, okay, the charges cancel each other out. Why is atom A unreactive? Let's have a quick look at atom A again. There you go. Off you go. Right, why is atom A unreactive? Atom A is in the noble gases, and the noble gases have a full outer shell, or highest energy level, or a stable arrangement. Anything with a full outer shell doesn't react, because that's what atoms want to have. They want a full outer shell to be stable, and so if it already has a full outer shell, it's already stable and won't react. Nearly all students got that right. Sorted. Which 2 of these atoms have similar chemical properties? It's 2 marks. Give a reason. So if it's 2 marks, 1 mark will be for naming the 2 atoms with A, B, C, D, and the other mark will be for the reason. So have a look at these atoms. I'll give you a clue. Look at the outer highest energy levels. Off you go. Right, so you should have got B and C. You are allowed to write lithium and sodium if you can work it out from the periodic table, which you can, because they are, first of all, they are all atoms, and that means if they are atoms, the number of electrons and the number of protons are the same. So then you go and count the number of electrons. 1, 2, 1, 2, 3. So then you look on the periodic table for something with the atomic number of 3, which is the bottom number in the element, which is the number of protons it has, and that is lithium. They have the same number of outer electrons, or they both have 1 outer electron. Or you could say they're both in group 1, because the group on the periodic table, the group number is the same as the number of electrons it has. What did the examiner's notes say? So I'm just going to get the periodic table up to help with this. Yeah, so it says that some students, the The students who identified the correct pair also got it right. The most incorrect pair was B and D, because they're in the same period. So if we go back to the question, so B and D, okay, so using this, A has 2 electrons, which means if it's an atom, it's got 2 protons, which means this is helium. Just do it to help you. So there you go, there's number 2. So that's helium. B is lithium, because it's got 3. So go up there, lithium's 3. C, 1, 2, 3, 4, 5, 6, 7, 8. 1. So 2 plus 8 plus 1 is 11. So that is sodium. So as you can see, they are in the same group. And then 1, 2, 3, 4, 5, 6, 7. So 7 is nitrogen. So yes, so lithium and nitrogen are in the same period. The period is the horizontal ray. The elements in the same period don't have similar properties. It's elements in the same groups that have similar properties. So lithium, sodium, potassium. So you've probably seen a video, or you've seen in real life, lithium, sodium, potassium being added to water. They all fizz. They all get smaller because they're reacting to make the hydroxide solution and hydrogen gas, so the solids disappearing. And they're all very reactive to water. You might have seen a video of rubidium and cesium. They blow up. So as you go down the group, they react in a similar way. They just react they're more reactive, but in a similar way. If you go across a period, lithium, if you stuck lithium in water, it would fizz and it would fizz. Beryllium would react with water, but not as much. Boron wouldn't react with water. Carbon wouldn't react with water at all. It's also a black solid in the graphite form. Lithium's a metal. Nitrogen's a gas. Oxygen's a gas. Fluorine's a poisonous gas. And neon's a gas that doesn't react at all. So as you can see, across a period, the reactivity isn't similar at all. The only thing that's similar in a period is that all the electrons are on the same shell, as in all the outer electrons are on the second shell. And if you're on period 1 with helium and hydrogen, all the electrons are on shell 1. Right, so there we go. And that's that. Right, question 2. Rutile is an ore of titanium. Rutile contains titanium dioxide. The flowchart shows how titanium metal is extracted from titanium dioxide. First thing you've got to think about this is read the information. You've probably never heard of rutile or titanium ore. It's not specifically on the specification, but it is similar to probably iron or aluminium. The information you presented will be similar to the information about iron or aluminium. So what have you got here? You've got the method of creating titanium from titanium dioxide. Okay, so there's a small bit about this in the textbook on the specification. Just that you need to react it with chlorine and then magnesium. Okay, so the first question is all about why is titanium more expensive than iron? So using this information and using your knowledge of how iron is extracted, and I'll give you a reminder that all you need to extract iron is carbon in the form of coke, which you can basically dig out of the ground, limestone, which you can dig out of the ground, and iron ore, which you can dig out of the ground, as opposed to chlorine, which you have to make through electrolysis, and magnesium, which you have to make through electrolysis. There we go. Off you go. Right, so why is it more expensive? Lots of reasons. There are many stages. More energy is needed. So electrolysis is when you stick an electric current through a molten compound, ionic compound. So you have to put loads of energy in to heat it up to melt it, because ionic compounds have a melting point several hundred degrees to about several thousand degrees, and you don't need that for ion extraction. Titanium cannot be extracted using carbon. So the mark scheme, less than half gain the mark. For those that said the extraction took several stages or more energy. So there you go. That's you can use the flow down and show that. Name the only waste products in the chart. There you go. There you go. Right, and the waste product is carbon dioxide, because it's the only one that leaves the chart. As you can see, all the rest sort of titanium leaves the chart, but that's what you want, so that's not a waste product. Everything else is reused somewhere else. Vast majority, good. Also, carbon dioxide is a waste product from combustion, so if people guess, they're probably going to guess carbon dioxide as well. Describe an example of recycling on the flow chart. 2 marks, off you go. Right, so magnesium chloride is electrolyzed, used, and magnesium and chlorine are recycled. So you get magnesium chloride when you react the titanium chloride with magnesium. What you then do is you put it back in electrolysis. So electrolysis, you take an ionic compound which has at least 2 elements in, and then when you do electrolysis, you separate them into their elements. So you get magnesium and chlorine back. So you get the chlorine back and the magnesium back to do more reduction of titanium oxide in. Of course, it's very energy intensive, which is why you don't do it all the time. Right, question D. The air is removed from reactor 2. An atmosphere of argon is to use for the reaction between titanium chloride and magnesium. Explain why. So, why do you get titanium chloride and magnesium reacting? Is a clue 1100 degrees. You're probably heating magnesium to that high in the air, so that will give you as a clue why. Off you go. Right, it is because the magnesium or the nitrogen would react with the magnesium would react with oxygen or nitrogen in the air. And argon is inert or unreactive, so you have to use the words inert or unreactive, or argon does not react. So yes, so whenever you do something at a high temperature, you're at risk of making it just react with the oxygen in the air. So when you did pollutants, when you're combusting hydrocarbons with oxygen, you're also combusting with nitrogen because it's such a high temperature. So you need to make sure the gases in the air aren't reactive. Right, next one. Titanium metal is produced by reacting titanium chloride with magnesium. 900 kilograms of titanium was mixed with 240 kilograms of magnesium. You've got 950 kilograms of magnesium chloride. To calculate the mass of titanium, I'm going to give you 3 words as a clue. Conservation of mass. There you go. Off you go. 240. Reason being, the product's mass has to be the same as the reactant's mass. So the reactants weigh 950 plus 240, which is 1190. You get 950 magnesium chloride, so you must have 240 magnesium. Or you don't even need to add these up, because you just go, oh, those 950s cancel out, so the rest must be 240. Majority. Oh, question D was poorly answered, so you need to remember your noble gases are unreactive. 2F, a graph. So the amount of titanium from impure ore and pure ore. Obviously, pure ore produces more titanium per kilogram per kilogram. 300 kilograms of titanium metal was produced from the impure ore. Calculate the mass of the waste rock in the impure ore. So there you go. Off you go. Right, so the answer is 250, or 245 to 250. So there you go. It was poorly answered. Determination, it was just a difference between 2 lines. So, yeah, so pure ore doesn't have waste rock in it. So you look at the 300. So it makes 300 titanium metal. So that's there. So that's about 475. And then if you go up to this one, then it's just the difference between two lines. So yes, it's quite hard to show on a thing, but if you've got a ruler, then you can show the difference is 250. Right, question 3. Crude oil, classic fractional distillation. Write a number 1, 2, 3, 4, 5 next to each stage so the description has been put in the correct order. 1 and 6 have done for you. There you go. 2 marks, off you go. Right, so the order is 1, 5, 3, 6, 4, 2. So, 1, 5, 3. So first, after heating, it evaporates. Then the liquids flow down and the vapours rise up. Then the hot vapours rise up to the column and cool. And then the fraction in the vapours cools at the boiling point, the fraction condenses. So fractional distillation, you get the crude oil, it's a mixture. The smaller ones, compounds in it heat up, vaporise. The very smallest go to the top where they condense. As you go down the column, they get bigger and bigger and bigger. You get some at the bottom which never vaporises because it's so big. Because the size of the molecule, the bigger the molecule, the higher the melting boiling point. Naphtha fractions crack to produce ethene. Ethene is used to make a polymer called polyethylene. Name 2 substances produced when polyethylene burns in air. It's got carbon and hydrogen. Off you go. Right, so the answer should be carbon dioxide and water, or carbon monoxide or carbon, because if you do incomplete combustion, that's what you get. Certain students didn't understand the process. 1 mark for carbon dioxide. So you've got to remember water. So when you burn something, it reacts with oxygen. The carbon reacts with the oxygen to make carbon dioxide. The hydrogen makes water. H2O. 3B, it's the big one. Billions of plastic bags are given free to shoppers. Well, this was in 2012. Now we have to pay 5p a bag. And this is why. These bags are made from polyethylene and are only often used once. After being used, many of these bags are either thrown away or buried in landfill. 10 billion in 2006, over 10 billion were given free to shoppers. In 2009, the plastic bags given to shoppers have decreased to 6.1 billion. One reason was because supermarkets made people pay for their plastic bags. In 2011, a new type of plastic shopping bag mainly from polyethylene had the use-by date in 1 year. Use information and your knowledge to describe advantages and disadvantages of using plastic bags made from polyethylene. So hopefully you should know about recycling, burning, landfill, the advantages and disadvantages of those. It's a 6 marker, off you go. Right, so you need a basic, for 2 marks you need a basic description of one advantage and disadvantage, or for 3 to 4 you need a clear description of advantage and disadvantage, and for 5 to 6 you need detailed description of advantages and disadvantages, so you need at least 2 of each for number 5. So here are the advantages and disadvantages. Simple properties, they can be reused. Money charged for bags goes to a good cause. They can be recycled, they can be burned, they can be made that are biodegradable. Disadvantages. Older bags take years to describe. There is a shortage of landfill space. Bags are made from crude oil, which is non-renewable. Large amounts of energy are needed. Production releases carbon dioxide. There's issues such as visual pollution or illiterate wildlife, and burning bags releases carbon dioxide. What did people say about that? Some students didn't get any marks because they did not add information in the stem of the question. So that's an interesting mistake to avoid. It says use the information above. So you definitely have to include information given. I know a lot of people would have revised this because it's AQA always has a question about environmental things. So there'll be there'll definitely be something about pollutants, even if it's just a 1 mark question about pollutants. And then there's things like bags, and then there's things like recycling metals, and then there's things like the effects of mining on the land. So there are plenty of environmental questions, and there's going to be at least one, and definitely something about pollutants. So a lot of people got that. Not many people got 11.3, and only where they give examples to litter. Vague examples like cause pollution. Pollution's never environmental damage. Yeah, that's never really an answer. You need to give a specific pollutant. Carbon dioxide is usually a very good specific pollutant because it comes up a lot. So if you write carbon dioxide, you're probably getting it right. So so there we go. Right, question 4. The atmosphere of Venus compared to Earth. You've never seen the atmosphere of Venus before. It's not on the specification. It's new. So you might get a lot of new information in exams. They give you this to test your ability to use this information properly. So they're deliberately giving you stuff you wouldn't have revised. Do not panic when you see something you haven't revised. Okay, just look at the information. It's probably deliberate because they want to see you use it. So don't think, oh, I've never seen this, I don't know this, I can't do this. Just look at the information and work out what it's relevant to. So this is to do with chapter 7, the Earth's atmosphere, because you've got the Earth's atmosphere and then you've got Venus's atmosphere. So why did the percentage of carbon dioxide decrease in the Earth's early atmosphere? So off you go. Right, and you should have written something like, dissolved in the oceans, marine organisms used it for their skeletons, limestone, and photosynthesis. Those are 3 possible answers. Majority of students got 1 mark for photosynthesis. Okay, people always forget that oceans absorb tons of carbon dioxide, so remember that. And also, animals that use calcium carbonate for their shells, etc., do it. And then the Miller-Urey experiment, you're supposed to have learned about this. So they stuck a load of gases that they thought was in the Earth's early atmosphere, passed an electric current through it, and tried to create molecules that are in living things. So they used methane, CH4, ammonia, NH3, and hydrogen. And they managed to get this thing. You've not seen it before. This is not on the specification. This thing specifically. Okay, they managed to get an amino acid. Okay, they show you the practical. Use the information on the diagram and page 10 to answer these questions. Why did they use methane, ammonia, and hydrogen? I'll kind of give you the answer to that. Because they were the molecules in the early atmospheres. Or an amino acid, sorry. This evidence only provides weak evidence. Why? Off you go. Because nobody knows what the Earth's early atmosphere was like. They may not have been using continuous lightning. They only selected gases that produced amino acids. So it was poorly answered and also poorly answered. So yeah, you need to read about the Miller-Urey experiment. If you have a book like this one, there is a whole double-page spread dedicated to the Miller-Urey experiments. C1 7.4, okay, there's half a page. The other page is dedicated to other theories about why life started. So there we go. Right, question 5, limestone. This is a limestone question. What is the substance that you react calcium oxide with to make calcium hydroxide? Off you go. The answer is water. You're allowed to write hydrogen oxide or H2O. And it's not well answered as expected. So sometimes even examiners have a good idea of which questions are supposed to be easy and which are hard. So obviously they're supposed to be easier. Calcium hydroxide reacts with a substance to produce calcium carbonate. Name it. The answer there is carbon dioxide, CO2, and then soluble carbonate. So there you go. Answered less. So this is all about the limestone cycle. And if you've ever blown into lime water, calcium hydroxide, that's lime water. You're making carbon dioxide when you blow out. Then the cloudiness you see when you blow carbon dioxide into lime water, that is small bits of calcium carbonate. Limestone reacts with acids. Buildings made from limestone are affected by the products from burning fossil fuels containing sulfur. Explain why. So this is the pollutants question. Right. Sorry, I missed a question. Balance the chemical equation. 2HCl, that's the only one you need. Right, so what is the thing? Sulfur reacts with the oxygen to produce sulfur dioxide, and then the sulfur dioxide causes acid rain. So that question is all about pollutants. There's always a pollutants question. So hopefully it was answered well, because everyone should know there's questions about pollutants. So everyone's doing the balancing equation. Make sure you can do your balancing equations. There'll be a balancing equation in every paper. C1, C2, C3. There you go. So most people knew about sulfur dioxide causing acid rain. Good. But you need to know its effect on limestone. It wears it away. Rotary kiln. Why is carbon dioxide coming out? Off you go. 2 marks. Carbon dioxide is produced from burning methane and produced from decomposing calcium carbonate. And the marks are poorly answered. Well, you need to know that methane is the fuel. And they thought that limestone. So this is what people get mixed up with decomposition reactions. It's confusing because you have one reactant. So most people think when you react something, you have to react it with something, but that's not the case. Decomposition, you are taking one thing and you are breaking it down to 2 things. So there is one reactant. So, and I know why else, because you're heating it up, which people might confuse with burning. But it's just like heating up some food. You're not burning it, you're adding heat to make it react. Name the other gas, another gas, and why is there a high percentage? Go. Nitrogen, because it's in the air as 75 to 80%. Don't think this was answered well. It was poorly answered. It's a bit of a tricky question because it's going in, not doing anything, and coming out. And you kind of get the clue when it says air. But I expect most people will be thinking, oh, what's a big gas that's been reacted, that's produced from a reaction? So, yeah, there we go. Right, question 6. Oh, this is the food chapter. It's a very short chapter, the food chapter. So basically, you're probably going to be asked about emulsifiers. So if I'm talking about the food chapter, it's plant oils. So it's about emulsions and emulsifiers, or the difference between cooking with vegetables versus cooking with water. They're the 2 main questions, because there is not very much. You might have to do distillation. I mean, it's in a practical box, so you might have to learn that. Oh, and lime water, saturated, unsaturated oils. There's not very much you can do in chapter 6. Why does the mixture and salad dressing separate? Off you go. Because oil and water doesn't mix, or they're immiscible, which is a word for doesn't mix. 3 marks. Why is French salad dressing not separate? Mustard has hydrophilic properties and hydrophobic. You may include a diagram to help you answer this question. Off you go. So, mustard is an emulsifier, or forms of emulsion. The molecules have a head which dissolves in water and a tail that dissolves in oil. So what is this diagram they're talking about? Hopefully, you will all have seen it. So I'll find the page to help you. And then I'll find a Google image as well. It is this image that we're supposed to know about. So this is an emulsifier with a charged head that dissolves in water and an uncharged tail which dissolves in oil. We say head and tail. They're not living things. They're molecules. We just say they have heads and tails. So the tails go in the oil and the heads go in the water. Okay, so I'm going to Google image. Here we are. Right. There we are. That is it. So that is the image they're going for. So that would get 2 of the marks because that shows that you've got the bit that dissolves in water and the bit that dissolves in oil. Okay. So diagram through either of those points. So hopefully, seeing as there's not much to learn for that chapter, yes, excellent explanations. That's a classic answer. Unsaturated and saturated. So this is another thing. Unsaturated means there's double bonds. Saturated means a single bond. What is the test? So it's a 2 mark. So 1 mark for the test and 1 mark for what you see. Go. Right. Classic answer. Bromine water turns colourless. Ignore clear. So there's a colourless means it has no colour. Clear means you can see through it. So you can see through coloured things like stained glass window. Many students didn't attend this question. Hopefully a lot of people have done it. If you haven't seen this practical, you can YouTube it. There's plenty of YouTube videos showing the bromine water test. Within hardening, so this is something else you need to revise. Making unsaturated fat saturated, so give the reaction and conditions. So you should have add hydrogen with a nickel catalyst at 60 degrees. That's something you need to learn. How do you make unsaturated oils saturated? It's the process called hardening. You add hydrogen with a nickel catalyst, 60 degrees. Many students didn't attempt this question. See, the bits about plant oils are really easy to remember. There's only so many things you can revise. It's a really short chapter. I'd suggest you learn it, and there'll always be a question about each chapter, so you'll have that locked down. You can do that one. Right, question 7, ethanol. So, there's 2 ways of making ethanol, from sugarcane or from crude oil. Okay, so it gives you a list of how each one is produced. So, complete a balanced equation for the cracking of the hydrocarbon to produce ethene. Off you go. Right, so to do this, ethene is C2H4, and then you've got one more product. How do you work that out? Well, remember conservation of mass. You've got 6 carbons here, 2 of them went into ethene, so there should be 4 left. 14 hydrogens, 4 went to ethene, should be 10 left, so it should be C4H10 plus C2H4. There you go. What is seen when the sugar yeast are used to fermented? Off you go. You will see bubbling because you're making carbon dioxide. But ignore gas given off or solution because you can't really see that very easily. Don't attempt. Make sure to not attempt. So you need to know your differences about between ethanol production methods. Crude oil versus adding water to ethene, hydrating ethene versus fermentation. Evaluate the issues of sugarcane compared to crude oil. It's a 5-mark question. Why is it important? Go. Right, so there should be both advantages and disadvantages. So, sugarcane absorbs carbon dioxide, sugarcane is sustainable, low energy, linked importance, so it's carbon neutral, saves resources, saves fuel. Disadvantages of sugarcane. You need land, which leads to destruction. Land can be used for food, so there's food shortages. It's slow, so limits it. It's impure, so you need to do something else to make it 100% pure. It's batch, as in you put some in, it happens, you take it out. The opposite of batch is continuous, where you just turn it on and it happens continuously. That's why it's continuous until you turn it off. Its crop yield is unreliable. Okay. Good. So there you go. So the good and bad points of using fermentation. Right, last one. Question 8. Some properties of dry air. Stuff you don't need to remember. They're giving it to you. Isolated nitrogen. You also discovered another gas. Because the density from dry air, because the density of nitrogen from dry air was higher than density of pure nitrogen. Use the information to explain why. So he knew about oxygen, carbon dioxide and nitrogen, but it was still denser. So why? Nitrogen, oxygen, carbon dioxide. What's going on? Go. Well, because nitrogen from dry air contain the noble gases. And 3 of these have a greater density than nitrogen. So yes, so this was before people had discovered the noble gases. The noble gases took ages to be discovered because they don't react. Okay, so these were in the air mixed with nitrogen. If you look at the density of nitrogen, it's 1.2506. Argon, krypton and xenon have a higher density, which means that the average density would be higher. Which is probably a hard question. It's a very hard question, so I guess not many people got that right. No, it needs a lot of information to work out. Okay, it says density in the question, so you need to be looking at the density column. It tells you you've got nitrogen, oxygen, carbon dioxide, so you get rid of nitrogen and oxygen and carbon dioxide, so you're left with the ones. So it's asking you to eliminate the ones in the question. You're left with these, then compare their densities. It's quite high level thinking, which is why it's the last question. So this is the process of fractional distillation of air. Carbon dioxide is removed, so suggest why. Give you a clue. Carbon dioxide melts and boils at -57. Go. Because carbon dioxide is a solid and would block the pipes. Which 2 gases do not condense at -200? Look at the information. Off you go. So the answers are helium and neon. Because if you look at their melting points, their boiling point, sorry, they are below 200, which means they haven't condensed yet. 2 gases in the air do not separate completely. Name these 2 gases and give a reason for your answer. Once again, look at this. Off you go. The answers are argon and oxygen because there's only a difference of 3 degrees. So yeah, so if you look at oxygen 219, argon, got boiling point. So fractional distillation doesn't get exact temperatures, it just gets a little range, which is why when you do it on crude oil, the fractions have about 4 different alkanes in them. Same with this. Okay, if the boiling temperatures are similar, they'll be together. And that's the end of the questions. Well, I hope you had a good time and you found this useful. Keep looking at my YouTube channel for more videos. I'm going to produce a lot more over the next few weeks for revision, and keep looking at my blog, The Virtual Science Tutor. Thanks, have a good time.